For over half a century, the lunar surface has been completely untouched by human hands. Breaking a 53-year vacuum in lunar exploration puts an almost unimaginable amount of pressure on NASA's ground teams. That pressure compounded around their primary vehicle, the Space Launch System. Leading up to the April 2026 launch, the massive rocket had faced a difficult development cycle, marked by budget overruns and a series of persistent hydrogen and helium leaks. As the clock ticked down to the opening of the launch window on April 1st, an anomalous sensor reading on the pad threatened to halt the mission at the final moment. This cross-section shows the Flight Termination System, or FTS. It is a mandatory safety mechanism consisting of explosive charges rigged to the main fuel tank. If a booster loses control mid-flight, ground control must detonate these charges to destroy the rocket before it falls on a populated area. Quickly resolving the sensor issue demonstrated that the ground team could maintain the countdown even under the pressure of a potential abort. It was the final hurdle cleared before breaking a half-century holding pattern. At 6:35 p.m., the most powerful rocket NASA has ever launched ignited its engines, pushing 4 humans up through a clear Florida sky. Aboard the newly named Integrity spacecraft were 3 American astronauts and Jeremy Hansen, the first Canadian to participate in a crewed mission to the moon. Below their capsule sat a service module manufactured in Germany. The highly integrated nature of this crew and their hardware reflects a new era of global collaboration in deep space. Reaching a high Earth orbit of 43,500 miles, the crew paused for a full systems check. Since this was the first time an Orion series capsule had ever carried people, NASA required a complete diagnostic before committing to the moon. Those checks revealed some distinctly human problems. The high-tech suction toilet, the Universal Waste Management System, suffered a suction fan failure. While it still worked for some things, the astronauts resorted to plastic bags for basic liquids. They also encountered a relatable technical hurdle. The crew found themselves completely locked out of their official NASA Microsoft Outlook email accounts. Despite the cabin glitches, the transit was precise. On the evening of April 2nd, the European service module fired its main engine for the trans-lunar injection burn, pushing Integrity toward the moon. This diagram outlines their free return trajectory. By locking into this specific figure-8 path, the spacecraft uses the natural gravitational pull of the Earth and the moon to handle the steering, without needing to fire the engines again. While the crew wrestled with broken plumbing and email logins inside the ship, the complex orbital mechanics of the transit executed with absolute mathematical precision. At a distance of over 100,000 miles, the crew captured this image, titled "Hello World." Using a Nikon D5, they were able to photograph the night side of Earth, visible only because of light reflecting off the surface of the moon. The crew noted that the moon is more colorful than it appears from Earth. Looking out the windows, the astronauts could perceive distinct hues of brown and even faint greens within the impact craters. As they drew closer, they crossed the 600-mile-wide Oriente Basin. This 3.8 billion-year-old crater marks the transition into the rugged, heavily pockmarked far side of the moon. From this vantage point, the crew could scout the South Pole Aitken Basin. This rugged terrain is the primary target for future landings and the eventual construction of a permanent human outpost. Passing behind the moon severed all communication with Earth. In that 40-minute radio silence, the crew witnessed an Earth-set and a 54-minute total solar eclipse, where the moon appeared much larger than the sun. By pushing humanity 252,000 miles from home, these observations replaced our grainy satellite imagery with a vivid, colorful understanding of the lunar landscape. After a congratulatory phone call from President Trump and NASA leadership, the crew spent 4 days drifting back toward home, right before the most dangerous phase of the mission began. As this trajectory shows, the entry angle has a razor-thin margin. If the capsule comes in too shallow, it skips off the atmosphere like a stone. If it comes in too steep, atmospheric resistance builds up too fast and overheats the ship. Dialing in the exact angle, Integrity hit the atmosphere at 32 times the speed of sound, causing the surrounding air to erupt into flames. The violent compression of air creates a 5,000-degree field of plasma. This energized gas conducts electricity, which blocks all radio signals and causes a terrifying 6-minute communication blackout. Surviving that blinding heat and a deceleration force of 4 Gs is the ultimate test of the vehicle's thermal shielding and the physical endurance of the human crew. At an altitude of 5,000 feet, the main parachute's deployed, slowing the capsule to a gentle 19 miles per hour for its splashdown in the Pacific Ocean. After a minor radio glitch forced the astronauts to wait for rescue boats, Navy personnel opened the hatch. One by one, the crew left the capsule and dropped onto an inflatable raft nicknamed the front porch. With the crew recovered and the data logged, Artemis II has provided the modern template for lunar transit. We are no longer relying on 50-year-old mission logs. We now have the technical foundation required to begin building a permanent human presence on the Moon.